Okay, in this video we're going to look at solving rational equations. Okay, so rational equations. So the first one we're going to look at is a very basic one. So we're going to look at 1 over x equal to 0. If we look at this and we try to find values of x that satisfy that, there won't be any. Okay, so there's no value of x that will make the left side equal to 0. Okay, and you can look at that graphically. So 1 over x looks like this. Okay, so the y value on this will never equal 0. So therefore there's no solution. Okay, we have something like x plus 3 over x equal to 0. Well, in this case, the value of x that might make the left side 0 would be -3. The value that makes the top 0. The value that makes the bottom 0 is not a solution. Okay? It's a value that cannot be used for this expression. So in this case, we have x equals -3 is the solution. And some people might write x equals -3, and then they might write x cannot equal 0. Well, that just doesn't make sense to write x cannot equal 0, because x cannot equal anything else but -3. So we're not listing the things that x can't equal when we're solving the equations. Okay? So if we had something like this one, where it's x squared plus 4x plus 3 all over, say, x squared plus x equal to 0. So if you had to solve something like this, first thing you're going to do is try to find out when the numerator equals 0. But we also got to factor the bottom, because we don't want solutions conflicting with numbers that can't be used in this expression. So we're going to factor the top. The top factors to x plus 3, x plus 1, and the bottom factors to x times x plus 1 equals 0. Okay, so in this case, well, we can cancel out the x plus 1's. If we see the same factor on the top as we have on the bottom, that's like a hole in the graph. So this expression doesn't exist there. So we can't say x equals -1 as a solution. So we cancel those out, and we don't have to write down the restriction here, because it's an equation. It's not just an expression, okay, or a function. So we don't have to write down the restriction. And in this case, we end up with the same answer as we had up above, and that implies that x equals -3. Okay? Now, what if we had something like this one, where we have x minus 1 over x equals x plus 1 over x plus 3. Okay. Sorry, I didn't see that. So, if we're looking at this one, well, we've got to bring everything to one side and have it equal to 0. Okay, so if we bring everything to the left side, x minus 1 over x minus x plus 1 over x plus 3 equals 0, well, then we can get a common denominator. Okay, so to get a common denominator, we're going to do x minus 1 times x plus 3 minus x times x plus 1 all over x times x plus 3. So if you need time to process this, just pause the video and take a look at it. Okay, so at this point, to get the common denominator, we're going to multiply top and bottom of this by x plus 3, top and bottom of this by x. And this is what we get. Now we've got an equation where the top of this is going to be a quadratic, and we want to leave the bottom factored, but we're going to have to expand the top, because it's not factored. We have a minus in between these two pieces here. Okay, so we got to expand that out. So we're going to have x squared. And so minus x plus 3x is going to be plus 2x minus 3. And then we're going to have minus x squared minus x. Okay. It's going to be over x times x plus 3 equals 0. Now the x squareds cancel out, and you get x minus 3 on the top, or x times x plus 3 equals 0. And now you can state that x equals 3 is the solution. Now some people might want to just cross multiply at this point. And that's dangerous because then you get rid of, well, you'll get the same answer as this at this time. You'll get lucky. But if you did cross multiply, you get rid of the denominator. And if you get rid of the denominator, you get rid of the possibility that something might cancel out from the top and the bottom, and you might list solutions that are not correct. So when solving rational equations, you need to get a common denominator. You're not to cross multiply. Okay? Now, what happens if we have something that's already factored, say x minus 2 squared times x plus 1 cubed x minus 3 all over, say, x times x plus 1 cubed equals 0. Or, sorry, let's not make that cubed. Let's just make that x plus 1 to the 1. Okay? Equals 0. Well, what would happen here is we could cancel out one of the x plus 1s. And we would write x minus 2 squared times x plus 1 squared times x minus 3 all over x. Okay, so we've canceled this out with one of those, make that a 2, and we've got this equal to 0. Well, now you would want to state that x equals 2, negative 1, and 3 are solutions. But you couldn't, so you have to write in here a little thing, because it disappeared from the bottom, you have to write in that x cannot equal negative 1 right here. Okay? And just to remind you that for the solution set, you can't include negative 1 because otherwise in the original you would have got a hole in the graph. Okay? So that implies that x equals 2 and 3 are solutions and not negative 1. Okay, that's it for solving rational equations.